Good morning students, welcome to your maths class. Now in last classes we have done uh, pair, ordered pair, now Cartesian product of sets, then we have done relation, how to represent a relation. So today's class we will do one new concept, that is functions. Now before starting function, let's see the definition. So here a function f is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no two distinct ordered pairs in f have the same first element. So in simple words, I can say that function is a special type of relation. But that relation must satisfy some properties. First one is, for that special relation, the sets A and B must be non-empty set. That means the both set must contain at least one element. Okay. Then the second condition is the domain of f is A, and that if I say the domain of f, the function f or the particular relation is A, that means, in other words, I can say that every element of the first set of that particular relation must be and must be the pre-image of any element. That means for every element of A, that is the first set, we must get an image in the second set. And the third condition is no two distinct ordered pairs in F have the same first element. That means suppose we have two sets A and B. Now for the set A, that is for the first set A, if we have an element A, then for that particular element A, we must have one and only one image in the second set B. So that's why it is written that no two distinct ordered pairs of F have the same first element. That is, for every element of A's first set A, there must be only one and one image in the second set B. So for, if we say that a function is a special type of relation which satisfies three properties. First one, the sets are non-empty set. Second one, every element of the first set is a pre-image of the second set. That means the domain itself is the first set. And the third one is no two distinct ordered pair in F have the same first element. That means for every element of the first set A, there must be one and only one image in the second set B. Okay. If f is a function from A to B and A, B, that means the ordered pair A, B belongs to that function f, then we can write that A under the function f is equals to B, where B is called the image of A under f and A is called the pre-image of B. Okay, so ordered pair AB, A is the element from the first set A and B is the element from the second set B. F of A is equals to B, then B is called the image of A under F and A is called the pre-image of B under F. Okay, so image and pre-image. That means every element from the set B is image and particular every element from the set A, that is from the first set, is pre-image. A function f from A to B is denoted by f colon A, then arrow B. That is function from A to B. So mathematically we will use this symbol f colon A to b. Then a function which has either r, real number, or one of its subsets as its range is called a real valued function. So further, if its domain is also either R or the subsets of R, it is called a real function. So we have different number systems. Okay, for this particular class we will see only the real valued function, that is from real number to real number. Its images are also real number and pre-images are also real numbers. Okay, so next we will see some particular functions and its graph. Okay, so let's start. So here some functions and their graph. So first of all, the identity function. Now what is an identity function? So let R be the set of real numbers. As we have already discussed that we will discuss only the real valued function, so that's why I have taken R the set of real numbers. Now let us define a real valued function f from R to R, and we will define the function as y is equals to f of x is equals to x. Now here this x is the element from the first set of real numbers, and this y is the image of this x which is from the second set of real numbers. Now the definition is like f of x is equals to x. That means if I take any element x, the image of x under f is again x for each real number x. That means if I take a real number, suppose 1, then f of 1 is again 1. If I take 10, then f of 10 is 10. If I take minus 2, then f of minus 2 is again minus 2. So in this way, if I draw the table of the image and pre-image under f, then I will get this graph. See, for 0, f of 0 is equals to 0. This is the y-axis and this is the x-axis, or you can say this is the axis for the image and this is the axis for the pre-image. So for 0, its image is 0, so 0 0, 1 1, 2 2, 3 3. Similarly, if I take minus 1, then its image is again minus 1, image of minus 2 and minus 2. Similarly, we will get the image of every element the same as the value of the element. So I can draw this line. So such a function is called an identity function. Here the domain and range of f are the graph is a straight line shown in the figure. It passes through the origin. Why it passes through the origin? Can you tell me? Because if I take f of 0, if I take the element 0 from this first set, then f of 0 is 0. That is why the graph passes through the point 0 0. Next, we will discuss about the constant function. Now the name itself says that it is a constant function. For constant means for every pre-image you will get the same image which is a constant number. So the definition itself is define a function f from the real set R to R by y is equals to f of x is equals to c for all x belongs to capital R, where c is a constant and each x belongs to capital R. Here domain of f is R. That means for every real number you can take every real number, but for every real number you will always get its image as c. So that's why its range is c. The graph is a line which is parallel to x-axis. If f of x is equals to 3 for each x belongs to capital R, then its graph will be a line as shown in the figure. Now see, for a particular case I have taken for every real number from this set R, its image is 3. So that's why if I take 0, then also I will get 3. If I take 1, then also I will get 3. If I take minus 5, then also its image is 3. So I will get a straight line. Okay, this is a particular case. Now for example, you can take f of x is equals to minus 7. Then for every value of x you will get only minus 7. That is, in this case your line will be minus 7 at 7 unit distance from that x-axis, which is below the x-axis because it is minus 7. So is it clear what is a constant function? Now these are important for your exam. Now see, there may be a question like, what is the range of a constant function? So you have to write the range of a constant function is equals to c if the function is f of x equals to c for all x belongs to capital R. Now if I ask what is the domain of a constant function, you have to say that the domain of a constant function is equals to R because we are considering only the real valued functions. So next is a polynomial function. Now you have already known what is a polynomial. Okay, so the name itself is a polynomial function. So definition is like this: a function f from R to R is said to be a polynomial function if for each x in R, f of y is equals to f of x such that f of x is a polynomial, like a0 plus a1x plus a2x up to anxn, where n is a non-negative and a0, a1, a2, an belongs to capital R. That means all these are real numbers. Now let us consider one example. F of x is equals to a polynomial x cubed minus x squared plus 2 and g of x is equals to x to the power 4 plus root 2x are some examples of polynomial function. Whereas the function h denoted by h of x is equals to 2x to the power 2 by 3 plus twice x is not a polynomial function. Now see, here I have given three examples: f of x, g of x and h of x. Now I have said that f of x and g of x are polynomials, but h of x is not a polynomial. Why? Because of the power of x. For polynomial, the power of x must be a what? The power of x may not be a fraction, a point. Okay, so this is a fraction, that's why h of x is not a polynomial. Now let's do one example. So here it is given that define a function f from R to R by y is equals to f of x is equals to x squared, where x belongs to capital R. What is the domain and range of this function? And you have to draw the graph of f. Now the solution is the given function f from R to R by y is equals to f of x, which is equals to x squared, where x belongs to capital R. Now let's draw the table. So in this table, first we have to take the value of x, then we will get the value of y. Now if I take x is equals to 1, then by this definition f of 1 is equals to 1 square, which is again 1. So value of y is equals to 1. Again if I take x is equals to minus 1, then f of minus 1 is equals to minus 1 whole square, which is 1. Similarly for 2 it is 4 minus 2 4, 3 9, minus 3 9, 4 16. Again minus 4 is equals to 16. Now you can take as many values as you want. Here I have taken this many values. So if you plot these values, along x-axis the values of x, along y-axis the values of y, you will get this graph. So this graph, this is a parabola which represents the graph of f of x is equals to x cube, where x belongs to capital R. Now the domain of the function f is equals to x such that x belongs to capital R. That means for every value of x, a real number, you will get a value, you will get an image. So domain of f is equals to R. Okay. So for today's class, we'll stop here. In the next class, we will do some more examples. So thank you.